So we'll see problem number 1. A 3-phase 6-pole star connected alternator has 48 slots and 12 conductor per slots on the armature. If the rotor is at 1200 rpm and the flux per pole is 0.3 Web, calculate the EMF induced in the armature. The coils are full pitched and the winding factor is 0.95. So write down the given data as 6 poles, 48 slots. It has been given 6 pole and 48 slots and 12 conductor per slot. Conductor per slot is equal to 12. That means say in one slot 12 conductors. Flux 0.3 Web. It has been given 0.3 Web. So these are given data. Now we have to use calculate the EMF induced. That is E phase is equal to formula 4.44 Kc Kd F phi T phase. So all these parameters we need to calculate now. So to calculate F frequency now, so we have got Ns is equal to 120 F by P, where Ns is given speed 1200 rpm, rotor speed has been given 1200 rpm, and from this we can calculate F as Pn by 120, 6 pole 1200 by 120, 60 Hertz. So that we got as frequency as 60 Hertz. Now to calculate T phase, what you have to do is you have to find out the Z phase, number of conductors per phase. Once you find number of conductors per phase, then we can go for T phase. How to find number of conductors per phase? For that you have to find out total number of conductors. How we can calculate total number of conductors? Conductor per slot is equal to 12 and slots as 48. It has been given. So we can find out conductors as 12 into number of slots. So 12 into number of slots, that's 48. That we found out as 576. Per phase, there are 3 phases, 192. T phase is equal to Z phase by 2. We know that in the formula T phase is equal to Z phase by 2. That will get as 96. So T phase we found out, flux we are there, F we found out. Then you have to find out Kc and Kd. How we can find out Kc and Kd? So in the problem it has been given as full pitched. If it has given full pitched coil, there is no alpha, there is no short pitched preference, alpha is equal to 0. So Kc is equal to 1. When it is full pitch coil, Kc is equal to 1. What about Kd now? Kd is same as 0.95. Why? Winding factor is equal to Kc into Kd. If Kc is equal to 1, Kd is same as winding factor. So 0.95. So by substituting all these values, you will get 7288.70 volts E phase. Then you have to find out line voltage. If it has been calculated, ask you to find out line voltage, root 3 into E phase, will get 12.624 kilovolts. Problem number 2. A 12 pole 500 rpm star connected alternator has 60 slots and 20 conductors per slot. The flux per pole is 0.02 Web and distributed sinusoidally. If the winding factor is 0.93, calculate the frequency, the EMF, the line EMF given. The coil is full pitched and winding factor is 0.97. So once again it has been given as full pitched coil. Kc is equal to 1, Kd is equal to 0.97. That you have to observe. Kc and Kd straight away you got from here, and flux 0.02 Web, just like in the previous problem. F is equal to Np by 120, 500 rpm it has been given. Number of poles 12 by 120 will get 50 Hertz. Frequency also found out. Phi it is already given. And now we have to find out T phase. How to find out T phase? We know that T phase is equal to Z phase by 2. How to find Z phase? Number of conductors per phase. To find out number of conductors per phase, number of slots per phase, number of slots, 60 slots and 20 conductors per slot. So conductors per slot, slots per phase, one phase 20 slots are there, because the total number of slots it has been given. So per phase 20 slots. Number of conductors per slot, how many number of conductors per slot? 20 is given. Conductor per slot is equal to 20. Slots per phase 20. How will you get now number of conductors per phase? If we multiply these two equations, we will get number of conductors per phase, that is 400. T phase, that we got as, Z phase we got 400, T phase that we will get as 200. If we substitute all these things in this equation, we will get as 816 volts, F 50 Hz, phi given 0.02, T phase calculated 200, KC 1 full pitch coil, KD 0.97, we will get as 816 volts, then E line is equal to 1492 volts. Next, the third problem. A three-phase star-connected alternator with the 12 poles generates 1100 volts on open circuit at a speed of 500 rpm. Assuming 180 turns per phase, distribution factor is 0.96 and full pitched. Find the useful flux per pole. So here we need to find out the flux. Here voltage has been given here 1100 volts. Always if it has given as 1100 volts, it is line voltage. Line EMF. We have to find out the phase EMF because we are applying formula for phase EMF 635 volts. Frequency NP by 120, speed has been given, number of poles has been given, we will get at 50 Hz. Formula, straight away substitute the formula 635, 4.44, flux we need to find out 180, from where it gets 180 now, so 180 turns per phase, it has been given. Full pitch coil, case is got 1, KD 0.96 given. So from this we can find out the flux as 0.0165 Web.